that today is our shortcuts for similar triangles. For congruent triangles, we had 5 shortcuts, right? Before we learned our shortcuts for congruent triangles, we had to prove all 3 sets of angles congruent and all 3 sets of sides congruent. And then we learned 5 shortcuts: side, 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 angle, side, angle, each other. Now for similar triangles, last class we talked about how similar triangles or similar figures, you have to show all sets of angles congruent and all sets of sides proportional. Who remembers what it means to be proportional? Cool.
The ratio is the same.
Wonderful. Our ratios are the same. So when we compare the sides, they should be the same value in the end. Now, last class we learned our angle similarity postulate, our first shortcut method to proving triangles are similar. And today we're going to learn 2 more shortcut methods. So there's only 3 shortcut methods for our similar triangles. And when you are writing these, when you're writing your reason for it, or when you're doing a proof, make sure you do include the squiggle to indicate that's a similarity and not the congruency. Okay. So this one is angle similarity postulate. You can just abbreviate AA with this squiggle. And it says if we have 2 sets of angles congruent, then we know that the triangles are similar. Okay, so here they've given us the angle, the measure. Ooh, that should say the measure. The measure of angle B is 100 degrees, which is the same for measure of angle Y. And the measure of angle C is 17 degrees, which is the same as measure of angle C. So just knowing those 2 pieces of information and nothing else about the triangles, I can make my conclusion that triangle ABC is similar to triangle XYZ. So it's pretty nice. We don't have to have a whole lot of information to know those triangles are similar. Angle similarity postulates. My favorite one because it's the least amount of work you have to do to show they're similar. You have the angles, boom, you know the triangles are similar. All right, questions with this? This is what we did at the end of last class. Okay. So now our second one is called the side angle side similarity theorem, and the smart board's going to catch up. Maybe. There we go. Say Canadian engineer. Alright, so our side angle side similarity theorem, or SAS squiggle theorem. Let me read this to you. If an angle of one triangle is congruent to an angle of another triangle. So if an angle of one triangle is congruent to an angle of another triangle. Okay, so we've got 1 set of angles congruent. And the sides containing those angles are proportional. The sides containing those angles are proportional. Then we know they're similar. Give me a moment to finish talking about that. Okay. So this is a similar setup to what we have for SAS for congruency, in that the angle is in between your 2 sides. Okay, so we call that the included angle, and that's what it means by the sides containing the angle. So it's the angle in between those 2 sides. And just a reminder, if you want to make a note for yourself, proportional means that they have the same ratio. Okay, so let's take a look at an example for this. And let me fix this. And suppose they give us, let's go with so we've got triangle ABC, triangle DEG. Got angle C and angle G are the same. And then we have BC is measure 5, AC is a measure of 2, EG is a measure of 20, and D is a measure of 8. Okay, so we have that the angles are congruent, and they gave us information about the sides that contain those angles, or that include an angle there. So we need to check to see if these are proportional. Do they have the same ratio? Alright, so let's go ahead and compare. Remember, when we compare, it's always best to match up small with small, medium with medium, large with large. So on my left triangle, which side is my smallest side? 2. So side AC. So I'm going to compare the measure of AC, and that matches up with what on my right, on the triangle right side? DG, good. So I'm going to compare AC to DG. That would be comparing 2 to 8. And then I'm also going to compare BC to DG. And that would be comparing 5 to 20. So we're not looking for the sides to be congruent. That would be congruent triangles. We're just looking for the sides to be proportional for similar triangles. Alright, so all we have to do right now, it doesn't look to be the same. We just need to simplify and see if they're the same. What does 2 over 8 reduce down to? 1/4. Woohoo! And what does 5 over 20 reduce down to? 1/4. Yay! They are the same! Okay, so my sides are proportional. They have the same ratio. And the angles in between are congruent. That means I can now say that triangle ABC is similar to triangle, and make sure you match it up properly. A goes with D, E, G. C and G should be in the same location. BC should be in the same spot as EG. BC, EG. So this one requires a little bit more work because we have to check those ratios. When you're checking the ratios, make sure you label what it is that you're working with. Label it, list the numbers, simplify. Now, as we're going through, it's possible that triangles get flipped around or rotated or turned. So make sure you do use that method of small, small, medium, large, large. Okay, questions with this one? Yeah, so that's shortcut number 2. All right, what do you guys think our last shortcut is?
Side.
It is side, side, side. So what we're checking this time is not that the sides are congruent, but that the sides are proportional. Alright, so for our side, 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 similarity there. What's different here, for our congruent triangles, we had to check that the sides were congruent. But for similar triangles, we are checking that the sides are proportional. The sides are always, we want to check always proportional, which means same ratio. Okay. So if the corresponding sides of 2 triangles are proportional, then the triangles are similar. Once again, it's SSS squiggle, it's similarity. We don't have sides are similar, figures are similar. We're checking that sides are proportional, so that same ratio. Alright, so it's going to be similar to what we just did for our second shortcut, but we have to check all 3 sides are proportional. So let's go ahead and come up with an example for this. Let's see. No one has a 3-letter name. Alright, no, we can do Bob, but then that's 2 B's. I think I'm taking your name, and we're just gonna go NIC. Thank you, Benaya. And let's go with Benaya. Let's do your initials.
Ready?
B, what's your middle initial?
T.
It's
Who did it?
oh, okay. All right. So let's suppose I'm gonna draw these triangles, and let's see. Anna, give me a number. 21. Okay. Said it, so we're going with it. Yes.
So if it's side to side, it need to be all sides instead of just two of the sides.
At the corresponding sides of two triangles. So we have two separate triangles that correspond sides. Yes, you're correct. All the sides of this. All right. Brian, give me a number.
40.
What'd you say? 42. These guys are killing me here.
Yeah.
Okay.
You guys choosing such big numbers.
Can I choose a number?
101.
Big numbers you
All
got.
right. Lady. 9. Thank you. Jocelyn, give me a relatively small number.
3.
Thank you. All right, we can do this.
Wait, that makes sense as that time.
Just trust the information, not the picture. Okay. Okay. So let's suppose that these two pictures were given to us. We have triangle NIC and triangle VTS, and these sides were given to us. So we don't have any information about our angles, but we have all kinds of information about our sides. We see that they're not congruent. We know that the triangles are not congruent, so the sides are the same. But we can check to see if they are proportional. And once again, we have to check every single set of sides. So we should have 3 sets of sides, right? And we need to label what we're finding. Now, pictures can be flipped, turned, twisted, all kinds of stuff. They will try to mess with you, so make sure you match up. Small with small, mirror with mirror, large with large. All right, what's my smallest side over here? 9. So NI. And that was 9. And what's my smallest side over here? 27. So VT. And then I'm going to check. My median here would be the NC. NC compared to VS. 21, 63. And then we can sneak in IC to TS. That'll be 42 to 126. Alright, these numbers are manageable. So again, every time you're checking proportions or ratios, set up by labeling what sides you're comparing, then the number squared. And now let's go and simplify. What is 9 over 27 reduced down to?
1/3.
Woohoo! That was easy. 21 to 63?
1/3.
Okay, now don't always assume the last one, but what is the last one?
1/3.
So because these all have the same ratio, I can say that these triangles are similar. So triangle NIC is similar to triangle BTS. Side, 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 similarities. And when you're doing these on quizzes and tests, I am checking that you have labels with the information back it up when you use that here. So this one, it requires, unfortunately, requires the most work because you have to check 3 ratios. So really, it's not bad to check ratios. You just have to sit back.
Let's say you don't show like how many points is it?
It would depend on how much the problem's worth, probably about half. Because the problem is that I don't know which triangle you're referring to. Right here, it's easy to see, but sometimes we have a number that's duplicated. So like you might have had 9 here and 9 over here somewhere, and then I don't know which one you're referring to. Okay, questions with this? Right, so these are our shortcuts. Today, we're just going to do some practice problems with these shortcuts and kind of using these to help us solve for unknown values. So go ahead for this next one, draw the picture here, and we're going to decide, are the triangles similar? How do we know? And solve the shortcuts. Let me zoom in on this for you guys.
That is really cool. Oh.
Yeah, I like that. how do you know, and solve for x. Do you guys think the triangles are similar? All right, what method could we use? Side, side, side? Angle, angle? We could actually use all three.
Oh, that's right.
Yes, we could use all three. So let's talk about this. What do we know about these triangles?
That they're equilateral.
They're equilateral. So that means that this side would be 10, this side would be 10, this side is 4, and this side is 4. So if I set up my ratios, that simplifies down to 5, 2. Well, isn't that the same ratio for every single set of sides? Okay, so we could say yes. Side, similarity, 0. Okay, now, how do I know angle, angle? No, go ahead, Jane. Good. So equilateral triangles are equiangular triangles. All of their angles are, what's the measure of an angle in equilateral? 60. So all of these are congruent, so we could say by angle, angle similarity. And then now that I have a set of angles congruent and the sides are proportional, then I could say by side equals side. So for this one, all three work. You do not need to list all three. It's not optimal. Okay, so we've got these three methods. That's how we know. So let's go ahead and solve for x. How do we solve for x here?
You put them equal to each other, so 4 over 10 is equal to 2x over 2x.
Good. So 4 over 10. So 4 over 10 is equal to 2x over 10x minus 10. Good, so we use that ratio because the ratio of the sides should be the same. Notice we kept that same order. And then we could simplify. Let's see, this was 5 halves. We could even reduce this, but we won't go too crazy. Can I reduce this? Is that allowed? Yeah, it's not allowed. We can only reduce fractions, one on top, one on bottom, on the same side. So be careful. That's a common mistake I see.
Why'd you do 5 half?
Yeah.
Oh, sorry, 2/5. Woo, that would have been bad.
Is that how much?
Can you just do 2x equals 4?
Can I reduce these?
Maybe.
Ooh, can I reduce these?
Yeah.
I wouldn't.
I don't want to confuse myself, so I'm just saying.
You could sneakily reduce them. I wouldn't normally reduce them. Okay, sorry. I got a little carried away with our, what can you do? Let's go and cross multiply. So I have 20x minus 20 equals 10x. So we get 10x equals 20. What do we get for x?
It's
2. Now, what could you have done instead of this?
Guessing check.
Not guess and check, Andrew. That's the last resort.
Since that's equilateral to say 2x is 4.
Good. We could have said 2x equals 4. Now, this only works because they're equilateral, or you could have said 10x minus 10 equals 10. Any of these will get you the same thing.
Is there a theorem that says all equilateral triangles are similar?
To my knowledge, no. But we could make that conclusion, right?
Okay, submit it to the National Math Board. I have a theory to look at. It's called the weight.
Okay. Questions with this? So for this one specifically, because they're equilateral, we could have gone the shortcut. But this is the idea of what we do every single time similar triangles. All right, our next one. The sides of the triangles are similar. State how you know, then solve for x. Back it on this picture. It's like a bow tie that went wrong. Did the marketing people leave yesterday?
New York.
Oh, yeah, they're staying.
National Marketing Board was the fight stuff. No, it's actually, well, this was very like, you know.
You can just skip the lectures. Okay. Jocelyn, Lainey, and Jamie, your grades should be updated on CIS with the Evans. I think that's what it's. And Aisha, yours is updated as well with that. Okay, so here we to decide if triangles are similar. Do you guys think they're similar?
Yeah.
I sure hope they're similar, otherwise we can't solve for x. Now, notice the order of the questions. You have to first decide they're similar before you can solve for x. If we don't have they're similar, we're not able to solve for x. So, we're out there. But let's go and take a look. They gave us information about our sides. Can you use side, similarity postulate there? No.
You could if you prove them similar, right?
So can I use that to prove similar?
No.
Why not?
Because if you like the circle thing, you can't use it.
Yeah, we don't know what the side is, right? So I can't use the side as one of my ratios because I don't know what the side is. So it's true it's 4x minus 4, but I don't know what the actual value is. I don't know that it would reduce down to the same ratio. So we can't use side. Do I have anything about my angles?
Yes.
What do I know?
Vertical angles are all
Good. So these two are congruent. Anything else with my angles? Nope. So I can't use angle. So my only possible option would be side, angle, side. So we're comparing the sides that contain those angles. All right. Now they didn't give us letters, so there's no way I can label what sides I'm comparing. But when we match this up, make sure you match up small with small, medium with medium. What's my small side here?
9 and 12.
Good. So 9 compared to 12, and then we're comparing 21 to 28. Notice I'm keeping that same order. Left to right, left to right. You could also do 9 to 21 and 12 to 28. All right, what does 9 to 12 reduce down to? And hopefully 21, 28? 3/4. Awesome. Okay, so side triangles are similar. Yes, they are similar by side angle, side similarity. Here. Okay. And we said how we know. Now solve for x. Okay. How do we solve for x here?
You can take your ratio, 3/4, and equal it to 18 over 4x minus 4.
Awesome. That's perfect. 3/4 equals 18 over 4x minus 4. I know my ratio. Just set up the other side of your proportion in that same order. I mean, we could simplify the right side, but I'm just going to go ahead and cross multiply. Now, you could cross multiply and multiply everything out, but since I know I'm going to have to divide in the end, I'm actually not going to multiply anything out. I'm going to do this 3 times 4x minus 4 equals 4 times 18. I could multiply it, but I don't want to have to deal with bigger numbers, so I'm just going to divide by 3. 4x minus 4 equals 18 and 3 reduce, 6 and 1 equals 20. And that's a lot easier to work with those numbers rather than doing 14 or 4 times 18, which is what? 50? No. Oh, golly, no. 74? 72? Thank you. See? And then having to divide that by 3. So it was a lot easier for me to just deal with factors. You don't have to do that, but I like to work with the factors rather than the big number. Alright, so what do we end up for x in the end?
7.
Alright. Common mistake that I keep seeing this year is that at this point, some of you guys are saying 4x equals 20 rather than 4x equals 28. So some of us might need to actually go ahead and write in that little step because we're still making that mistake of not doing x. Alright, questions with this one? Okay. Do I want this one next? Okay, Kyle says yes. No. There's the other class I didn't do. Did you say a bad word with it there? It's just because it's been zoomed in. The pixels have been super duper enlarged. Alright, so same song, same dance. Are the triangles similar? If so, state how you know and then solve X. Wait, it says are the triangles similar? What triangles is it talking about?
Oh, I know this one.
Yes, Benaya.
It's the small one on top and then all of it together.
Beautiful. Thank you. So we have our small triangle on top, and then we have the big triangle. Sometimes I think it's beneficial to draw these separately. You'll see why in just a moment. Okay, before I fill in information, can I say that these triangles are similar?
Yes.
How?
Angle, similarity.
How did you know angle, Lee?
Because since you have the two lines of parallels, you can use the corresponding angles to show that they're similar.
Good. Do you guys agree with Lainey? Yeah, we have corresponding angles there. We actually know something else. What else do we know? What about that top thing there? It's the same angle, right? We're going to go with reflexive property for that one. But we do have that. Now, obviously, once you have the two, you don't necessarily need the third, but just to make sure you get it. Okay, so we do have that the triangles are similar. So yes, angle, similarity. Okay. Excuse me. So now this is why I think it's beneficial for us to set up our triangles separately. You don't have to, but a lot of students make mistakes with this one if they don't draw them separately. So for my small one, this is pretty easy to see. This is 6 and x minus 1. For my big one, this is 2x plus 4. And then what's my other side? What is this? X plus 6. So it's that entire length here, x plus 6. Personally, when I'm doing these problems, I like to go ahead and separately write x plus 6. Just so that way when I'm setting up my proportion, I'm not tempted just to say x. That's the big mistake everyone makes, is they say the top one's 6 and the bottom one's x, but it's not. It's the whole thing x plus 6. Okay, so now we can set up our proportion. Now that we know the triangles are similar, now we can set up the proportion. So x minus 1. So 2x plus 4. So I did bottom of the small, bottom of the big, equals, side of the small, 6. Side of the big, which is x plus 6. Okay. Again, you could have gone in a different order. It does not matter as long as you're consistent. I could have done 6 to this, and then x plus 6 to that one. Or I could have gone bottom to top, or top to bottom. Alright, let's go ahead and solve this one. So we cross multiply. And we have x minus 1 times x plus 6 equals 6 times 2x plus 4. Do you guys agree with this? Do you agree with what I have here? I don't.
Can't you simplify it to 6?
Ooh, can I do this?
No.
Nope. Because for n subtraction, they have to both have 6 with it, so we can't do that. But there's still something wrong with this statement. Jamie,
X minus 1 has to be in parentheses.
yes, x minus 1 has to be in parentheses. This entire quantity has to be multiplied by that entire quantity. So now what do we have to do with this? We have to FOIL it out, and then we take the whole thing and factor it. Wonderful!
Wait, we have to.
Multiply it out, and then move everything over.
Oh,
Factor. Sorry. You're like, why would we multiply it out if we can already factor it?
Yeah.
Okay, so I get x squared plus 6x minus x. Did you say what's wrong with me? Or is that- And then I have 12x. Alright, I want to see what you guys can do with factoring. We want everything on one side. So move everything to one side and then factor it to solve. Feel free to work with your shoulder partner. Feel free to do it on your own and check in with your shoulder partner. Let's see what you get for x in the end.
Oh, I. You have to make it easy. Once you get your answers, I want you to check with. 2 people are around you. It's cool, but it's very cool.
I thought
Actually, it was 15. Because everyone knows that wasn't like
What did I do wrong?
X squared plus 5x.
X is not like.
I could have done it wrong too.
She got yeah, so I got that wrong.
Oh, good.
Okay, so you
Because you're using these to check my work. So I was waiting to see what
and then you have -6 remaining. Oh, that's fine.
I'm hearing some good things that we're communicating with one another, and then I hear, oh, I messed up this is good, we're catching each other's mistakes. We exchange experience with 2 people.
It is 10.
Same things, good.
15.
Really not bad.
Okay, so here we have x squared and it's positive. So it's not
Oh, no, I think it's 10.
What was the point of that?
You need to say 12x.
It did nothing.
You want 62 tenths?
Old Navy.
It's only X.
Alright. What did you guys get this to factor into?
X minus 10, X plus 3.
Do we agree with Lainey?
Yes. I agree. 10? Yeah.
Okay. And so then we get x equals 10. X equals -3, but we have to check to see can we take one, both, or none.
Oh.
One.
What do you do?
What is that?
No, because -3 minus 1 is -4. You can't have a negative.
Alright,
I mean, negative 2.
I take 10 and put it in.
Yes.
That works. If I get -3, put it in. Don't automatically get rid of the negative just because it's negative. You need to actually check the question. Alright, so we have x plus 10. Any questions with that one? Alright. Our next one requires you to write a little bit.
Oh man, no.
I will read this off to you to make it a little bit easier for you to write. At 4 p.m., Carl. Isn't Carl a guy off The Walking Dead? That show still going on? It is.
I can't see from here.
Carl, that kills. Wait, was that the little boy or is it the?
That's the boy.
Is that undead? Rick. Yeah. Rick Ryan. Is it called Rick Ryan? Okay, so at 4 o'clock p.m., write this down on your paper. At 4 o'clock p.m., Carl stands next to his house. Let's see everyone writing. At 4 o'clock p.m., Carl stands next to his house.
4 o'clock.
At 4 o'clock p.m., Carl stands next to
We
his
have
house.
to write the whole thing down. Can we just keep it up and then look back?
So when you look back at your notes later, you're not going to have it. You won't know what in order you're doing. But now you're writing this down. At 4 o'clock p.m., Carl stands next to his house
4 o'clock, isn't it?
and measures his shadow in the house's shadow.
And what?
Measures.
How is he supposed to measure his own shadow?
Yeah. You can move it.
You have the measuring tape that, goes up. You know what I'm talking about? And then, you hit it, it's like, zoop, and rolls back up.
Why
job.
Yeah. It makes me back.
Accurate.
Because when it goes out, it was like at
I don't even know.
Yeah, but then it's down. It doesn't work.
At 4 p.m., Carl stands next to his house and measures his shadow in the house.
Yeah, we put up the units.
It took a little longer to measure the
This
house.
does not work.
This house is 32 houses tall.
Carl's shadow is 8 feet long. Carl's shadow is 8 feet long.
Carl's house is 6 Carls tall.
What?
Girl 6.
The house's shadow is 48 feet long.
The proportion is 6 over 8. 40.
If Carl is 6 feet tall, how tall is his house?
8.
Your mathematician.
The house is
Alright. They love to do problems like this for our similar triangles. Now there are a few assumptions that we make in the world of high school geometry. Anytime we're talking about a figure, so someone standing on the ground, a flagpole, a tree, a house, we assume that they're all upright and thus perpendicular to the ground. Okay, so the entire Pisa we're not going to be doing problems with.
What about that woman?
Alright. The other assumption that we make, which is true, is that the sun casts the shadow at the same angle. So we're going at exactly 4 p.m., not at 4 and 5 p.m. So let's go ahead and draw a picture. Here's Carl's tall, skinny house. Here's little Carl.
Carl's.
Oh, poor Carl.
His house
He's
is
stuck in the house.
36 feet tall.
Oh my gosh, it is. Alright, so Carl's shadow is 8 feet. And the house's shadow is 48 feet.
Dang.
Tower.
Okay? And then they tell us that Carl is 6 feet tall. And we're trying to find how tall is the house. So I'm just going to put the exit. Right. Now, with this, we can actually create 2 triangles out of this. Here. Here. Now, I personally like to draw the triangles separately. So I'm going to draw Carl's triangle separately. I find it's a little bit, for me, it's easier to visualize what's going on. So this is 6, this is 8, and this is Carl. Alright. So again, in our high school geometry class, we're not going to go with things falling over. We're going to stick with ones that are standing straight up. So we know that these are perpendicular to the ground, so they both have a right angle. Also in our geometry class, the sun is casting the shadow at the same angle. Okay, so this angle is going to be the same as this angle. The sun is casting the shadow at the same angle. Alright. So we now have 2 triangles. In order to set up a ratio, we have to have that they're similar. Do we have that these triangles are similar?
Yes.
Yes.
How?
Angle. First, we know that all right angles are congruent, and then we say angle.
Good. We've got that they're congruent by the angle. They both have the right angles, which are congruent, and then the angles from our sun. Alright. So that means we can indeed set up the proportion. Alright. Now, we're trying to figure out how tall the house is. We're going to call it x, and then my x in here. Alright, so again, it doesn't matter which order you go in, just as long as you're consistent. So I'm going to go x to 6 is equal to 48 to 8. Do you guys agree with that?
Yeah. Cool.
So again, you could go in a different order as long as you're consistent. Yes, Michelle?
Can I use something else as a name?
Indeed. Now, I would probably actually just simplify over here. But you could go ahead and you could multiply both sides by 2 if you wanted to reduce that way.
I think I did 8 or 6.
Oh, so yes. Okay. All right, so I'm going to go and reduce. What does 48 reduce down to? 6 and 1. And we could cross multiply, or I'm just going to multiply by 6 on both sides. So I get x equals 36. All right, so let's make sure we answer the question. What are they asking for? How tall is this house? Is that what x represents?
Yes.
Yeah, okay, so the house is 36 tall.
Feet.
36 feet. And let's just make sure that answer makes sense in the context of our problem. Carl's shadow is longer than him. His height was shorter, so we should expect that the house's height is shorter as well. So we see it as shorter. Okay, questions on this? Yes.
Okay, how would the sun's angle be the same? Like, I feel like when we
It's
it
far
would be
enough-
very similar.
You're correct with that. You are correct with that. So that's why in our high school class we're seeing the beats in because it's so far off. It's a minimal amount that would not make a difference here. But when they use this for actual mathematicians use it for big time stuff, they do have to take in consideration that it's going to be slightly off. But for us, because the sun is so far away, it does not impact our scenario here. Now, if we're talking about I'm not sure how big the building would have to be, but it would impact it at a certain point. It would be like probably like 36.0000000 something, which would make more sense. But you're correct with that. It is slightly different.
Who are Kyle?
Yes.
Would you like to know what hypotenuse is?
No.
Grace says no.
Huh?
You know this one, right? What's this one?
Yeah.
What's this guy? Very good. Okay, that's called a Pythagorean triple. We're going to learn those.
The Pythagorean.
March. All right, any questions with this? All right. Yes. Well, I don't know about the blitz, but you will have to get one. 3 minutes. All right, let's do this one. How
Oh!
about this?
Need a-
I won't make you write it down. We'll just do it together. All right.
Oh, there's one more. Oh, we don't have enough time.
Are the triangles similar?
Yes.
Good. Angle similarity. So I can set my proportion. All right. 2x to 21 equals
40 over.
All right, I want you to do some mental math. Ooh, that's not easy. Saul, what do you get for x? Oh my goodness, wait, we have to factor?
No, you don't. Stop it. I don't really want to.
My brain.
Ellen, that's a good answer.
You don't say. Ooh, yikes. This is not nice.
That's like my age. I started to read it. I started to read it. And this is-
I'm listening to like hours.
840.
Here's another.
Oh.
All right, so what's your homework for tonight? This worksheet.
What is
It's 213.
No, I'm smarter.
It's whatever that's.
It's so hot, smart. Kyle, that Kyle doesn't start. No, I start. Were you on Alright. Everything equals time.
Who beat it?
No, I'm.
It's not from that. It's because
Oh, yeah, so you like.
but if that's true, they give us but we don't know.
No, I'm not. Don't teach Kyle. We're not guys. You don't teach Kyle.
I'm sorry, Justin.
Wait, how that's Oh my god. You lost by 2.
Yes, and today after school until 4, and there are late buses sitting at 4:30. Guys, I'm after school day if you want to come and get help. What's that?
I know.